Hello, calculus fans. Let's talk about a different type of indeterminate form, and that's an indeterminate difference. Let's say you have the limit of f of x is infinity and the limit of g of x is infinity. Then what happens is that the limit of f of x minus g of x is an indeterminate form. It is of type infinity minus infinity. The idea is that they're both getting big, but we don't know which one is getting big faster. So in order to evaluate this limit, we're going to want to convert it into a single quotient. We want to convert it into quotients because that's how we use L'Hopital's rule. We hope we can convert it into a quotient that's of type 0 over 0 or infinity over infinity. There's a lot of techniques for getting this to happen. Common techniques include making common denominators, rationalizing, or factoring. And we'll see some of these in action. Okay, so let's do an example problem. Let's evaluate the limit as x approaches 1 from the positive side of 4 over log x minus 4 over x minus 1. Now we should note that the limit of 4 over log x is infinity. That's because as x approaches 1 from the positive side, the log x is getting close to 0. And the same thing with 4 over x minus 1. As x gets close to 1, x minus 1 is getting close to 0. So both of those things are getting close to infinity, but when we think about the limit of the difference, we don't know which one's getting big faster, so it's an indeterminate form. This is an indeterminate form of type infinity minus infinity. So in this case, we're going to make a common denominator in order to try to deal with this limit. All right, so let's take our limit and make a common denominator. So it should look something like this. 4 times x minus 1 minus 4 log x all over x minus 1 times log x. This is of type 0 over 0. If you see what's going on the top and you see what's going on the bottom, they're both going to 0. That tells us we can go ahead and use L'Hopital's rule. All right, so if we differentiate the top, we'll get 4 minus 4 over x. And the bottom, we'll need to use the product rule, and we end up with x minus 1 times 1 over x plus log x. I'm going to try to clean this up. So the top can be made into a single fraction, 4x minus 4 over x, and the same with the bottom, can be made into x minus 1 plus x log x over x. So we have a compound fraction, which can be simplified into 4x minus 4 over x minus 1 plus x log x. Notice that we still have the limit. We have not yet evaluated the limit. Except for the step where we use L'Hopital's rule, all we've done is a little bit of algebra in each step. Now, this is another limit of type 0 over 0. You should be able to see that the top is going to 0, and the bottom is also going to 0, because x log x, this portion of it here, is going to 0 because the log is going to 0. So we can differentiate again. We'll get 1 plus, and then in order to differentiate x log x, we need to use the product rule. We'll get x times 1 over x plus log x. Make sure you're working out all these derivatives. And also make sure you're not using the quotient rule. We're just using L'Hopital's rule, where we separately differentiate the top and the bottom. All right, so you get 4 over 2 plus log x. And now, at this point, we can go ahead and plug in 1 because it's not going to cause any zeros in the denominator. That is to say, we can use the direct substitution property. And now we end up with 2. And that's our final answer. So in this problem, we had to make common denominators and then use 2 applications of L'Hopital's rule to get the final answer. Okay, that's all for now.